Let's have a little recap. Finance formulas, and probably the first one you ever saw was this idea of simple interest, and it is a very simple formula. I equals PRT, where I is that simple interest, P is the principal, how much you're borrowing or how much you're saving depending on the type of question. R is the interest rate. Now the way I've written the formula, it's as a decimal or a fraction. And T is the time periods. Some people write it as PRT over 100, but then the ratio has to be a percentage for that formula to work. So you got $3,000, you're going to invest it for 7 years, 6% simple interest. What will it be worth after 7 years? Work it out or sub it in, and the interest is $1,260, but that's not what they've asked us for. They want to know how much the whole investment's worth, so we need to add that on, and we get the $4,260. Compound interest, of course, is what happens in the real world. And there it is. And I wrote it in this form because if you look at it, that's just a geometric series. There is a times r to the power of, well in this case n rather than n minus 1, but it has that same shape. So it really is just a general term of a geometric series. An, it works out the whole amount for us, so it adds the interest in as well. P is still the principal, but for this one, because we're doing the whole amount in one hit, it's 1 plus the interest rate, not just the interest rate. And n still is our time periods, of course. The thing we have to be careful with the time periods here, because we're compounding, we need to match the time units for both the interest rate and the actual periods we're using. Let's do the same question, but now we're going to compound, and we're going to compound annually. Now when we sub it in, we get $4,510.89. Let's see what happens when we compound monthly. PR to the power of n. But now we're changing it, because it's compounding monthly, the interest rate has to be per month, so that's 0.5% per month, but then the time period, so we're 84 months, not 7 years, and we get slightly more. Depreciation is when the value goes down. It's the same formula, there's no difference. The difference, of course, is we subtract the rate rather than add the rate, and that will make the value go down instead of the value going up. An espresso machine. Don't drink coffee myself, and I can see why if they cost $15,000. I guess this is not one that you put in your home. It depreciates at a rate of 12.5% per annum. What will its value be? Wow, this is an old question. In 2010, if we bought it in 2001. So A is PR at the power of n, subbing it in, and there's our value. During which year will the value drop below 10% of the original? And we're saying, when will this general term be less than 10%, which would be 1,500? So let's solve this little equation. Log both sides, bring the end to the front. Again, we've got a log that's less than 1, so it's a negative number. Change the sign, we get 17.2. So that will be during the 18th year, so 2018. Okay, that'll do us on our recap.